Math 3 Classwork 7.5. The first thing you're going to do is just sketch a basic graph of sine x. I said to do it in pencil, but it's the idea that you're going to kind of highlight or recolor some things as part of the graph. So sine goes through the origin. It's at 1 at pi over 2, back to pi, back at pi, sorry, at pi you're back at 0, 3 pi over 2 down to -1, and 2 pi back to 0. Now, if you look at what I wrote about the interval, I want you to sketch it from -pi over 2 to 2 pi. So I'm going to go backward to -pi over 2. And it looks like the negative sign got cut off on my picture there. Now, what I want you to do is use a pen or a highlighter or something to highlight the interval from 0 to pi over 2. So that little section right there. Now, are you familiar with the horizontal line test? Is everyone familiar with the horizontal line test? Are you familiar with the vertical line test? Okay, so some are, some aren't. The vertical line test is a test to determine if something is a function. So if I were to draw, here, I'm drawing like a sideways parabola. If I draw a vertical line through a sideways parabola, it crosses it more than once. Or I can at least draw a vertical line that will cross that graph more than once. That means that that graph is not a function. At least, particularly, it is not a function where x is the input variable and y is the output variable. Because to be a function, every input variable is only allowed one y value to go with it. Now, if I draw a parabola that is right side up, it does pass the vertical line test. That means that any line that I draw that is vertical will at most cross it one time. Now, the horizontal line test, right, the horizontal line test is drawing horizontal lines instead, and it's determining if the inverse of the graph is a function, because with inverses, x's and y's will swap. So the horizontal line test is looking at if I draw horizontal lines, I just erased the whole graph. If I draw horizontal lines, will I cross the graph more than once? If so, then I have failed. The horizontal line test determines that if you cross a graph more than once for any horizontal line, then the inverse of that graph is not a function. In order to work with inverses, we need to be able to work with functions that are one-to-one. Functions that pass the vertical and the horizontal line test, because then every single xy coordinate, when you swap them to create a yx coordinate, you aren't running into the question of duplicates. Like if you say, hey, my x coordinate is this, you know which point on the inverse function you match with, because its y coordinate is your x coordinate. Anyway, so for part C, it's a question. If you were to continue forward highlighting the graph from pi over 2 to pi, would that entire highlighted portion pass the horizontal line test? So would this pass the horizontal line test? No. So the answer is No, that would not pass the horizontal line test. So now I'm going to erase those. Put the word no back on. Now, what if I go backward and continue highlighting the graph from negative pi over 2 to 0? Will that entire highlighted portion, the blue and the yellow together, will they pass the horizontal line test? Yes. And then basically D is make sure it's highlighted. And so I'm leaving it as highlighted for the yes answer. Then for letter E, write the interval that is highlighted in the graph that passes the horizontal line test. So that means you're going to write negative pi over 2 to positive pi over 2. And what you want to understand is when you get out a calculator and you ask it to do the inverse sine, it gives you one answer. And you need to understand that this was a human choice. And what I'm taking you through right now is the process of that human choice. Every one of your 6 trig functions passes the horizontal line test if you take the section that is 0 to pi over 2. In addition, 0 to pi over 2 are quadrant 1. They are the first 90 degrees that you work with. They are where actually we begin a lot of our trig with right triangle trigonometry, where you have an acute angle in a right triangle and you do the SOHCAHTOA thing. So that 0 to 90 degrees is something that is like the most important structure of the angles that you work with at all times with any of these trig functions. So you will always take 0 to pi over 2. But you want to take the longest stretch of the graph that will pass the horizontal line test. And what you're going to find as we go through all 6 graphs is that it's either going to pass the horizontal line test if you continue it to pi and do the 0 to pi range of angles, or if you instead go backward to negative pi over 2 and use negative pi over 2 to positive pi over 2. That's the point of these first 6 pages, are to literally see why what has been chosen for the angle range for each of the inverse functions is that chosen angle range. And this is reviewing your graphing and that kind of stuff. So anyway, blah, 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 blah. I need to remember what it was that I intended to tell you. So there's my typed up answer. All right. So I want you to put in this first box right here, this -1 is the symbol for inverse. But unfortunately, while the symbol for inverse comes from the number -1 used as an exponent, when we put -1 in a position of an exponent on a function, we no longer want to look at it as a -1. We want to look at it as a symbol for inverse. It's not an exponent of -1, even though it looks like it. And I know that's very frustrating. It's an issue. It's a huge issue. Because it's so annoying, some people started writing the inverse trig functions in a different manner. And that's where I want you to write the second box. It means exactly the same thing. Both of these are just different ways to write the exact same function. And we say arc sine x when we're using this notation. We usually say inverse sine when we're using this notation, but they mean one and the same. Now, here's some unfortunate things that you need to make sure you are very, very clear about, because this creates confusion through all levels of math. I get a lot of calculus students that don't realize this specific notation issue, and it causes problems. Do not confuse the notation inverse sine with the notation sine squared x. Know that when we write an exponent on a trig function, if that exponent is a positive integer, see, here's an unfortunate thing. Math people decided to make a language to communicate with each other, and they decided, hey, you know what? I'm tired of writing a parentheses with an exponent. How about we all just agree that we're going to write it this way, and we all understand what it means. Can we do this? Can we do this? And everyone says, oh, yeah, that's so much faster to write than it is to put a parentheses. Are math people lazy? That brings it into serious question. So a choice was made by humans that this was going to mean a certain order of operations of x goes into a sine function. That sine function takes place, a y coordinate comes out, and then we square that function. If we intend to cube a function, we write it this way. And let's say it's tangent. If I write this, know that this means tangent x to the power of 4. So because this notation was chosen for exponents, and because somebody decided that this was going to be the notation for the inverse function of sine, people get this extraordinarily confused. You need to know that while, let me erase a little bit so I can emphasize. You need to know that while this notation is true, this notation is incorrect. We view this symbol as not the number -1. We are viewing it as a symbol for, hello, I'm the inverse function, which is a completely different function from what we would get if we made an exponent of -1 on our sine function. If we make an actual exponent of -1 on our sine function, that means reciprocal function, which means cosecant. Now, there's a bit of a difference between the graphs. I'm going to grab a Desmos, and I'm going to show you that I am typing in the particular functions. And in Desmos, you can actually go over to the function menu, and you can ask it to graph sine. You can ask it to graph inverse sine. What I'm going to do is I'm going to graph the inverse sine function so you can see how it is defined. This is the graph of the inverse sine function. I want you to see that the x interval of the sine of the inverse sine goes from -1 to +1. Come on, there we go. When you look at the range of this function, the range of this function is that the lowest y is -π/2 and the largest y is +π/2. So it's an inverse of sine because all the x and the y coordinates were swapped. Now, if I graph the reciprocal of sine, and the reciprocal of sine is the function cosecant, I get an extremely different function. Look at the difference. Those two graphs have absolutely nothing in common. They are completely different. They have different domains and ranges. So I can't emphasize enough to you that there is a difference between this symbol and an exponent of -1. Now, back to all of this. So I've got a lot written up to really push this issue because it is a huge, huge deal. All right. Now, perhaps you got bored and you moved forward and started the next piece. So here we go. Cosine. Does everyone remember how to graph cosine? Cosine starts at its highest point when I'm at input angle 0. Then it hits the midline, lowest, midline, top. And spilt bowl of cereal that is still holding the cereal to eat. Spilt bowl of cereal. I want to, however, look at its graph all the way back to -π/2. Like the previous problem, I want you to highlight the section from 0 to π/2 and know that that section of the graph is used for the inverse cosine function. Then the question is, if I continue highlighting forward and I highlight the π/2 to pi, will I get a function that passes the horizontal line test? Or if I go backward from -π/2 to 0, will that graph with the yellow highlight pass the horizontal line test? And the answers are yes for forward, no for backward. And I'm going to now erase and leave that. So that's the highlighted section that I'm asking you in part D to highlight. Now, part E. What is the interval that is highlighted? The highlighted interval is angle 0 to angle pi. Know that that is the angle that we use for the inverse cosine function. And we write inverse cosine by either doing cosine with an inverse symbol, not a -1, or we write arc cosine. And then the x is the input variable, and you have to write something down right after where I have it highlighted. You have to write something where I have it highlighted in order to say this is what's going into that inverse cosine function. And I do have this typed up in case you couldn't read clearly what I was writing. So there you go. Okay, now, hold on one second. I want to double check something. Okay, yeah, I wanted to double check how I was doing that. Okay, here we go. Next, we have tangent. Do you remember the graph of tangent? Everyone draw tangent. It's partly a refresher. Tangent goes through the origin, and it has an asymptote at π/2 and -π/2. It asymptotes again at 3π/2. And remember that tangent is equal to sine over cosine. When a denominator is equal to 0, you will get asymptotes. Cosine is 0 at -π/2, π/2, 3π/2, and all those multiples. And then you want to remember that the graph of tangent heads upward as you go left to right. So as I go from asymptote to the next asymptote, I head upward. Also, when the sign is equal to 0, it crosses the x-axis, but that's always halfway in between asymptotes. And I asked you to draw this graph from negative pi over 2 to 2 pi. And then we're going to go through the same process again of first highlight the graph from 0 to pi over 2. Then take a look at forward versus backward. If I go forward over to pi, I want you to realize something. If I take this graph from 0 to pi, the horizontal line that I draw at y equals 0 will go through 2 points. That is the main reason why we cannot go forward with tangent. But a better reason is the inverse graph is a really nice, pretty graph if you just take a section between asymptotes. Let me redraw that. So you want to know that when it comes to the inverse tangent function, that function is understood to only use the angles between negative pi over 2 and positive pi over 2. Now, when I have you write down the answer in part D, know that, part E. Know that I'm keeping the answer in a more simplified format without concerning ourselves with where the asymptotes are. Because technically where the asymptotes are, I can't use those angles. But to keep it more general and just have a basic idea, I'm going to say that the highlighted interval is from negative pi over 2 to positive pi over 2 to keep it simple and not worry about the fact that technically the endpoints aren't in the angle range. You're not going to need to worry about that. Then when I write tangent as a function, I'll show you the typed version since it's typed. We have the writing it with the superscript of a -1 that refers to the inverse function, not an exponent of -1, and then writing it as arctan of variable x. Okay, next, we're going to do cotangent. So I want everyone to remember, how do I graph cotangent? I would say first start with the fact that cotangent is cosine divided by sine. When denominators are equal to 0, you will get vertical asymptotes. Sine is equal to 0 at 0, pi, 2 pi, and all of their multiples. The graph will go through the origin, or sorry, let me rephrase that. The x-axis. The graph will have an x-intercept when the numerator is equal to 0. Cosine is equal to 0 at pi over 2, at negative pi over 2, and 3 pi over 2, and all their multiples. Now with cotangent, it's helpful to remember that its graph heads down as you draw the graph left to right. So if I start graphing here at negative pi over 2, it's going to head downward. And then as I cross over the asymptote, I've got to stop up higher, or start up higher, and then draw downward. Start up higher, draw downward. All of the trig functions use 0 to pi over 2, so highlight that section. That part of the graph will definitely be used for the inverse cotangent function. But then the question of, do I go forward another pi over 2 or backward another pi over 2? And based on what we just saw with tangent, know that it's going to be forward. And technically, we can't go backward because if I go backward to negative pi over 2, then that means I can draw a horizontal line that goes through 2 points if I take the negative pi over 2 to positive pi over 2. So we actually can't use that part. And that means that the interval that we use for cotangent is going from 0 to pi. And again, while the endpoints are places where the function does not exist, I'm just going to write it as a closed interval to keep it in a more general idea of using a section from 0 to pi, not concerning within yourself with the asymptotes and all that. And how do you write it? So you write cotangent with a little -1 exponent that is not a -1 but means inverse, or you write arc cotangent of x, and typed version is always better. There you go. We've got 2 more to go, and then we're going to really dig in. And I'm going a little bit quickly through this because we've got work ahead. Okay, secant. You want to remember that secant is the reciprocal of cosine. So when cosine is equal to 0, secant has vertical asymptotes. Also, you can do a very light draw of a cosine graph. La 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 la, la la la, la la la, la la. Whoopsies. La la la, la la la. And go backward. La la la. Where it crosses the x-axis, those are vertical asymptotes of its reciprocal graph. Where it has a y value of 1 and -1, that is where cosine and secant share their graphs, and then it looks like that. All right, now here we go. Just like before, you're going to highlight 0 to pi over 2. The question is, do I go forward to pi and use that interval, or do I go backward to pi over 2 and use that interval? You can probably see that if I go from negative pi over 2 to positive pi over 2, I will certainly not pass the horizontal line test. If I try to draw horizontal lines, they go through it twice. So, oops. Yeah, I'll deal with it. So that means that continuing it to pi, it will, yes, pass the horizontal line test, but going backward, it will not. But now we're going to highlight 0 to pi. And the thing that people don't always like about the inverse of secant is that there's an asymptote in the middle of the graph. But I'm going to tell you that you're not going to worry about that right now at this level of math. You just want to see that humans had to choose the angle interval that was going to be used as the inverse function's angle range. And so that means that the inverse secant function uses the interval from 0 to pi over 2, 0 to pi. Technically, pi over 2 is not, cannot be used, but we're just getting a general idea, not going into the fine details. So then I'll just show you the typed up answers of inverse secant and then writing it as arcsecant. I'm going to keep going and then do this last one fairly quickly. Remember that cosecant is 1 over dun, 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 sine. If I draw a little sine function and go, wee, 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 I can then draw cosecant by taking every x-intercept of sine and making a vertical asymptote. And every high and low point of 1 and -1 is where sine shares its graph with cosecant. Then I'm going to highlight 0 to pi over 2, which is always used for every one of the trig functions. You should see that if I go forward, I will not pass the horizontal line test. I want to go backward. And again, I have this unfortunate asymptote sitting in the middle of it, but all you're concerned about is realizing that the inverse cosecant function uses the angles from negative pi over 2 to positive pi over 2. And arc cosecant variable. All right, now there's a summary, and you may need to write this down later because I need to make sure to cover some certain pieces of information. You need to write this summary because this is ultimately all that we care about at this point in math about what we just found. And that is the realization that if you are using certain inverse trig functions, let me start by saying this. When I use a forward trig function like sine, my input is an angle. My output is the answer that I would get if I looked at a ratio of opposite over hypotenuse with some positive negative issues thrown in there. When it comes to inverse sine, its output is an angle. And you need to know that you are only allowed to answer angles that are either from 0 to pi over 2 or go backward from 0 to negative pi over 2. That means that if you are told the inverse sine of, I'm going to go with -1/2. If you are asked what is the inverse sine of -1/2, you're actually asking if the answer to sine is -1/2, what angle will get you there. But there's only one allowable answer. So you look at the y-coordinate -1/2 and you identify which angle. That is the angle negative pi over 6. Now, in the past, when I have given you equations like this, I have asked you to find all the angles from 0 to 2 pi, and you would have found two angles And actually, this wouldn't have been one of them. You would have answered 11 pi over 6, and then on the other side of the circle, 7 pi over 6. But when you are given the actual inverse function, there is only one answer allowed, and it has to be in the angle range that is understood. Lucky for you, you're going to have notes when you sit down to take tests. But know that this angle range goes for these three functions. And I've heard some people remember it as Santa Claus climbs up a chimney. See, climbing the chimney? I don't know. But I like better the don't spill your cocoa seek. Spilled bowl of cereal looks at angles just 0 to pi, all forward going. Now, also realize that you've got what I call co and non-co pairs. Cosine and sine are what I call a co-non-co pair. One of them gets the 0 to pi, the other one gets the negative pi over 2 to pi over 2. Cotangent and its non-cotangent, so cotangent and tangent, one of them gets the upside down cereal bowl, the other one gets the Santa Claus chimney. And then you have cosecant and secant. They're the only ones that it's almost like they're spies of each other's co-worlds, shall we say. So cosecant has the same angle range, or inverse cosecant has the same angle range as inverse sine and inverse tangent, but secant, the inverse function, is the same as cosine and cotangent. That will be an important thing for your notes. Now, drum roll. What are you going to be doing in homework tonight? What was the point of everything we've been doing? It was to get you to, here are your first examples. You are going to find two positive angles with your calculator. Find two positive angles that are solutions to each equation theta. What I want you to do is use your calculator, and you need to understand that when you use your calculator, you're only going to get one answer. So I'm going to walk you through this. Have your calculator out that you plan on using. For number one, if I'm using a calculator, then I need to find the inverse sine of 2/3. That's going to give me one of the angles that gives me a value of sine that is 2/3. I'm going to grab Desmos since I can show that on here. Oop, come back, Desmos. And you can use Desmos like a calculator. Trying to get it to, hold on one second. All right, here we go. I'm going to take these out. And with your calculators, you're going to push one of these buttons. I'm only going to focus on these three because all calculators use these three buttons. We're going to not use these keys. So you're going to put inverse sine, and then you're going to put 2 divided by 3, but make sure that's in a parentheses, and you're going to get an answer. The answer is, and round your answer to 3 digits after the decimal point. So 0.729 rounds up to 0, so 0.730 is what you're going to write down. This is the answer that my calculator gives me. That is a positive number, and that number is between 0 and 2 pi. And what is 2 pi? If pi is 3.14, what is 2 pi? About 6.28. So know that what you're looking for are answers that are positive but less than 6.28. Now I want to take you back to the unit circle in full. I just got an answer for sine, and that angle is about here. This is that might be a little too far, but yeah, it probably is a little bit too far. 1 radian this is less than 1 radian. You may remember that 1 radian is an angle where the radius is equal to the arc length. So 0.730 is going to be a little bit shorter than that. So let's say this is approximately the angle 0.730. If you were dealing with the sine function, sine is a y-coordinate. The other angle that has that y-coordinate is horizontally on the other side of the unit circle. Now, I'm going to let you use formulas on your test. Remember that as we do this. What I want you to first do is see if you can logically understand what we are doing. My calculator gave me an answer for sine. If I take the radian measure of pi and I subtract that same angle measure, I will find the angle that has the same y value as this angle. That means I'm doing pi minus 0.730. So let's take out the calculators. And then I'm going to type in pi minus, and I'm just going to go ahead and put in the rounded number. You can use the rounded number, or you can put in the previous answer to get something more accurate. The answer is 2.41, and I'll round up to 2. 2.412. 2.412. Is 2.412 a positive number? Is 2.412 less than 6.28? What you have right here are two angles that solve this equation. And now you see how you can use your calculator to solve that equation. And if you need to know any other angles, any other solution is going to be coterminal with one or the other of these angles. So any coterminal angles can be found by adding or subtracting 2 pi to either of those numbers. So in the end, okay, keep going. There we go. So what I've got written for the answers are an explanation of, first, use your calculator. You have to make sure you're in radian mode, by the way, not degree mode. Then we're going to find out that that formula works to use pi minus whatever angle that I just got. So the answer that I got here is my theta that I'm referring to here. And both of these angles are in the interval 0 to 2 pi. So those are my answers. And voila, done. Over. Okay. Now we're going to do the next problem. Why does it keep going all the way back to the beginning when I switch back? Okay. For the next problem, I'm going to do sine again, but we need to look at the difference of the situations. Okay, I'm trying to wall off the work on number 1, and here's the work on number 2. The first thing you're going to do is find the inverse of negative 0.9 with a calculator. I want to remind you that the summary we looked at a moment ago told us that our calculator will only give us an answer that is either an angle from 0 to pi, or an angle that is pi over 2, or an angle that is 0 to negative pi over 2. We are only going to get an angle in that range when we use our calculator. So I'm going to bring back up my Desmos calculator, and I'm going to use the function inverse sine again and type in negative 0.9, and it gives me an answer, negative 1.119, but I'm going to round up, so negative 1.120, negative 1.120, negative 1.120. Is that a positive angle? It's not. That means it's not one of my 2 positive angles. Now, what I want to focus on for you is there are certain steps you're going to take with every one of these problems. And that is, 1, use your calculator's inverse, get an answer. 2, use the formula to use the sine formula. Later, we're going to talk about the cosine and the tangent formulas. The sine formula that we're going to always use, I should actually write it this way. The sine formula to find the other location that uses that number as an answer to sine. Do pi minus that number, and it's going to work. And I will show you with the diagram. I got a negative angle that's way down here. So here's 0. Here's my initial side. So negative 1.120 radians is approximately this angle. Now, if I draw the whole circle and look at this as the xy plane, I need to find the angle that is horizontally across from this one. And the easiest way to find that angle is to realize that this negative angle that I just turned should be the positive angle that I use from pi. But if I subtract a negative angle, I am adding, which is what I really wanted to do in the first place. So the formula of pi minus theta is going to work every time you use your inverse sine function to find the location of the angle on the other side of the circle that your calculator will not tell you about. No matter what problem you work on, you will first put it in your calculator. You will then use a specific formula that will be given to you. And find that number. And I'm going to grab the calculator again. And I am now going to calculate pi. And I'm going to write plus and then 1.120 equals, oh, wait. And I'm getting 4.261 rounds up to 2, 4.262. 4.262. Now, between the two numbers that I now know are angles that make this equation true, are both of them between 0 and 2 pi. This one is, but the original one I found isn't. So I need to do an extra step if my calculator is giving me a negative angle to follow the directions of find the two positive angles. The reason I want you to find two positive angles is for you to get an understanding of how you can use your calculator to solve your trig equations, and how you can get more answers as well. So what I'm going to do is I'm going to find a coterminal angle for my negative angle by adding 2 pi. So negative 1.120 plus 2 pi. And then put that in your calculator. Negative 1.120 plus 2 pi. And now I get 5.163. So my two angles that are between 0 and 6.28 are these two. And I'm going to show you how it's written in the answers and show you the comparison of how I have it written here. So it's always start with the calculator, then use the formula for sine. If both of your answers are positive numbers, you're done. If the first number that you got was a negative number, you need to take it and add 2 pi, and then you have your two positive numbers, and you are done. And that is basically what you're going to do for each of these, except cosine and tangent have different formulas. And because I only have 5 minutes left in class, and I'm going to have to go straight over to the formulas. And actually, did I? Yes, I have a nice drawing to go with them. I just talked about the formula for sine. The formula for cosine, if you need to find the angle partner that is having the same x coordinate, you can take whatever angle answer you got and go 2 pi minus that angle. If the only answers you're able to get out of inverse cosine are somewhere from 0 to 2 pi. If you have an angle that goes out, say this far right here, if you subtract that same amount from 2 pi, that will get you to the same vertical position of the angle. So that's your second formula. Tangent, you should already know it. For tangent to find a second angle, it's always directly across the unit circle. Just add pi. Now, as we are running out of time, I'm going to have to do a quick run through of the remaining examples. When you use the inverse cosine button of your calculator for 0.37, you are going to get 1.192. Then you will find the second angle using the cosine formula. Both of those answers are between 0 and 6.28. You're done. Now, I have across from it doing cosine with a negative input. If inverse cosine has a negative input, you actually end up with an angle that's between pi over 2 and pi, but it's still positive. Use the same formula, 2 pi minus theta. You get an answer. When it comes to cosine, you don't have to worry about getting any negative answers for your angles. It will always give you a positive answer. And so you're just going to follow those steps and boom. For tangent, like sine, is allowed to go into negative angle range. So I'm presenting here two versions of tangent. One where your answer to tangent is positive, one where it's negative, to show you the two situations you can run into. With your calculator, you will find the inverse tangent of 2.5. Then you will add pi to that angle. Both numbers are between 0 and 6.28. You're done. But for this negative answer to tangent, when you put it into your inverse tangent function, it's going to give you this negative number. Now, just like you did over here, you're going to add pi and get the number that is across the unit circle. That second angle that you're getting with your formula is always going to be one of the positive angles between 0 and 2 pi. But if your calculator gave you a negative angle and you need the positive coterminal angle, add 2 pi to that number, and you'll have your two numbers that are between 0 and 6.28. And I just barely made it before class was over and people started bailing. The formulas are right here, and enjoy your homework. And